The broadcast is now starting. All attendees are in listen-only mode.
Hello, and welcome to this week's webinar by the IChemE Safety Centre, where we're going to talk about process safety concepts. My name is Trish Kerin, and I'm the Director of the IChemE Safety Centre, and I'll be taking you through this webinar today, so thank you for joining me. If you have any questions along the way, please feel free to put them in the questions panel in your control panel that you have to GoToWebinar. You can also send me chat messages via the chat function as well. Once I go through the slides, I'll then be trying to address as many of your questions as I can during the hour that we have scheduled. So without further ado, let's get underway. So first of all, we want to talk about what is process safety. If we want to talk about process safety concepts, we need to first of all go right back to what is process safety all about. And I've highlighted a couple of words in here in red because I think they really sum up the absolute key critical aspect here. What we're looking at is for a loss of control event that may lead to high consequences. It also should be stated that this is potential consequences as well. We don't actually have to see the high consequences for it to be a high potential event that might have had a different outcome in a slightly different situation. So overall, we're about managing the integrity of the operating systems, making sure we use inherently safer design principles, engineering and disciplined operating practices, prevention and mitigation of incidents that have the potential for this loss of control of material or energy. And so that's the key element about what process safety is actually all about. And there's a couple of things that differentiate it quite clearly from occupational health and safety. Now, occupational health and safety is very important, as is process safety, but it's also quite a different field. It's not any easier, but it's actually different. So typically what we see is the mechanisms of causation are different. So whilst we're looking for predominantly losses of control of hazardous energy in process safety, we're usually managing high levels of energy when we're talking about process safety, so that can be quite a concern as well. The scale of the potential consequences can be quite different, and without doubt, an OHS incident can result in a fatality, and that is an unacceptable tragedy. Typically, though, in process safety, we talk in multiple fatalities from the one incident, and so the scale of consequence that we're talking about is quite different as well. The focus is on engineering and design in process safety, a little bit more than it is in OHS, although there is still very important OHS design implications that need to be taken into account. But predominantly process safety is about how the person impacts the process. OHS is typically about how the process or equipment can impact the person. So that sort of sets a little bit of a scene in that way. I just want to take you through a couple of reminders of some of the major incidents that have occurred, because it's always important to just have a think about some of these and understand a reminder of some of the magnitude of it. So if we go back to 1984 in Mexico City, there was an LPG, liquefied petroleum gas explosion that occurred and resulted in a number of other explosions and fires. And there were more than 5,000 fatalities in this particular incident. So again, we're talking multiple fatalities here. The same year in Bhopal in India, we saw the tragedy that unfolded when a toxic substance was released over a sleeping town. And there were thousands of fatalities in the Bhopal incident. And this really shaped a lot of the ways in which we approach process safety today, so that we hopefully never see anything of that magnitude ever again. The Herald of Free Enterprise. Now, this is a ferry. I've deliberately put something in that you would not think of as being process safety related. But if you look at the loss of control element and the consequence, this certainly fits the definition that I shared earlier. So this ferry, it's a car ferry and passenger ferry. It sailed with its bow doors open, took on water, capsized, and 193 souls were lost in that ferry incident when that occurred. Back in 1998, we saw Piper Alpha, which anybody working in the offshore industry should be quite well familiar with. This incident actually shaped a little bit of how we now work with permit systems and how we manage those. It also changed some design requirements within the offshore sector as well. 167 hands were lost when that platform sank. So certainly, again, a very tragic multiple fatality event. Longford in Victoria, Australia, where I'm from. Now, this incident had 2 fatalities, so that's certainly nowhere near the extremes of talking about the thousands in Bhopal, but nonetheless, those 2 people, their families suffered terribly for their loss, and there were a further other 8 injuries in this incident. And this started to shape how we do major hazard activities within the Australian region as well. Another example, Texas City Refinery in 2005. So we're now starting to get into the 2000s. Some quite modern and recent incidents have occurred. And this incident killed 15 people when there was an explosion on startup of a particular part of the plant after some maintenance shutdowns. And the explosion occurred and flattened a nearby trailer where a meeting was taking place with people in it. And so, you know, that's really focused industry again on occupied buildings. Buncefield in the UK that same year. Now, this one had no fatalities. And that was really only a matter of luck because of the day of the week the incident occurred on. So it could have been a lot worse when you see the damage to the surrounding buildings, but it occurred on a Sunday morning, so there was no one in the surrounding office buildings. Deepwater Horizon, I'm sure you're all familiar with or have heard of this one in the Gulf of Mexico in 2010. 11 fatalities in this instance. An oil spill into the Gulf of Mexico for approximately 3 months, and some quite significant impacts there for the company. And lastly, very topical, very recent, being Beirut, the explosion that we saw in the Beirut port area earlier this month. Over 200 fatalities in this particular instance. And I've had a lot of people actually discussing with me on LinkedIn and debating that they don't believe this is a process safety incident. It was just it's all about storage and regulations and following the rules. And I would argue that it was a loss of control because the rules and storage and appropriate containment processes weren't being followed, and the consequence was certainly quite high. And I don't think there's value in writing off incidents as saying, oh, that was just a storage issue, it should never have happened, therefore we're not going to talk about it as process safety. I don't think that adds value to the process safety conversation. So I would still suggest that it is a process safety related incident in itself. So the sorts of impacts we see from these incidents are quite substantial. Injuries and fatalities, environmental damage, disruption to communities, reputational damage to the company and the industry, legislative reaction. So some of these incidents that I just talked about actually led to changes in laws. Impact on business performance. There's a whole lot of issues around there as a significant incident in terms of how the business goes forward when it's had such a significant impact to it. And the Bhopal example is an example of where the business ceased to actually exist following the incident. Prosecution and litigation obviously can occur. And as I said, those business-ending incidents, certainly we saw that in the Bhopal example as well. So the challenge we've got is that process safety is complex. There's no getting around that. There are inherently safer design principles that need to be followed, looking at things such as green chemistry and how we can actually use less hazardous substances potentially within our processes. A quantitative assessment with detailed mathematical calculations can be complex. Doing pressure relief calculations, for example, a lot of these mathematical things people find challenging and complex. But that's not just what process safety is about. Process safety is also about your management systems, your culture, human factors. And these are all complex, but in a different way. So it's important that we just take a moment to think about that. The subjects that I'm talking about here, they are complex subjects, but the communication doesn't need to be complex. We need to be able to explain process safety to others so they can understand it, because we need them to be engaged in the activities to deal with process safety and make sure we get good outcomes. If they don't understand what we're saying, then they certainly can't participate in the activities that we need them to participate in. So we need some uncomplicated practical terms to help communicate the risks that we face. And so that's a challenge that we've got. Now, there are ways and different methods and different management systems that we have right now in the world. So process safety management system defines how we manage process safety across an organisation, and this is really important. There are probably 2 main frameworks that exist in the world. One from the Centre for Chemical Process Safety in the US, that's called Risk-Based Process Safety Guidelines, and one from the Energy Institute, which is the Process Safety Framework. And both of them are very comprehensive, excellent management systems to apply in your organisations or to gap assess against to make sure you've got those areas covered adequately. So an example of what's in a process safety management system, and this is a summary of the Centre for Chemical Process Safety version. You can see here it's got 4 pillars: commit to process safety, understand hazards and risks, manage risks, and then learn from experience. And then there's a number of subtopics that go with that. And they're all very, very important aspects. And this allows us to think about the system, the management system we have, and how that works within our organisation. And the system approach is very logical and very thorough, and it covers all the input requirements that we have, and it defines all the outputs as well. So they're vitally important to have in place, whether it is an embedded system, an integrated system in your business that is used to be, say, the OHS management system that also covers the environmental management system. You might have all of these in an integrated management system, or you might have standalone systems, a process safety one, an OHS one, an environment one, all separate. There's no right or wrong answer to that. It's what works for your organisation, provided you're covering everything and it actually works for you. If we think about the functional elements of an organisation, it actually allows us to think in terms of outcomes. And that's a little bit different. And it simplifies the requirements so we can talk in outcomes for non-technical people. And it's important to remember that these two systems are complementary. They're not opposing each other and they're not replacements for each other. They're actually quite complementary together. And so a framework that we could talk about that focuses on the functional elements is one shown here. Now, this is the IChemE Safety Centre framework that we use. So we talk about leadership across 6 areas in the organisation. And it's important to note that, for example, if one of these areas is deficient or not functioning properly in the organisation, then there is a risk of a process safety event occurring, and chances are that dysfunction or issue that's occurring will actually be occurring throughout the entire organisation. So it's important to think about these as they permeate through all of the organisational aspects. So what I'm going to go through now is each of these different areas and talk a little bit about them, what they mean, and how you might be able to apply them within your own organisation and where they might actually have an impact, depending on what your type of organisation is or what different stage of the life cycle your facility might be in, for example. So we'll go to leadership first. And if we think about what is leadership, there's been a lot of research over the years on what is leadership. One of the most common definitions that seems to be most widely accepted now is that leadership is a process, which means it can be learnt because it's all about a process. It involves more than one person. So by very definition, if there are no followers, there can't be a leader because there's no one to follow the leader. So that's an important differentiation there. It's all about influencing people, not about managing people. A manager is different to a leader. And so there's we need to make sure that we do understand that distinction. Where management might have some authority to be able to dictate something occurring, leadership is actually about influence to get the outcomes. You get a better outcome when the people that you're working with actually want to do the work, they want to do the task, they haven't just been told that they have to do it. And it focuses around a common goal. So it's all about, in summary, a process that involves more than one person influencing others around a common goal. So whatever that common goal particularly is, so it might be leading the organisation. The common goal would be to deliver outcomes for the organisation. There'd be a series of sub-goals in that. It needs to be done safely. It needs to be done on budget. It needs to be done on schedule, for example. That would be the sub-goals around that. But overall, this is what it's about. So I like to summarise it personally in it's enabling people to be their best and get where they need to be. That's what I try to focus on as a leader and what I try to work through with people. So if we now go to the first of those 6 areas that sort of surround the leadership sphere for us, let's talk about knowledge and competence. So You can think about knowledge as being the familiarity, general awareness, or understanding of the impact of one's actions. Whereas competence is the ability to perform activities and to undertake work functions to agreed standards, requirements, and procedures on a regular and consistent basis sustainably. So competency is actually a combination of practical and thinking skills and experience and knowledge. You can have knowledge and still not be competent in something. So generally, competency is the outcome of training both on and off the job, and that's an important thing to understand there. So training off the job, for example, is doing a training course on something. That will give you some knowledge. That doesn't give you competency. You need to then go and practice and experience it. So there's a general rule of thumb that was developed several years ago, and it can be often debated as to whether the percentages are correct, and the percentages are really neither here nor there. But the theory is that 10% of your competency comes from the technical training aspect of it, 20% comes from being coached and mentored in the role, and 70% comes from the experience. Now, whether that's a different percentage split, as I said, that doesn't really matter. The important part is that we need to acknowledge in competency that it requires all three aspects to be done. You need, if you think about it from the perspective of driving a car, you study for your test so that you can sit the written test to get your license. So that's your knowledge bit. You might know the road rules, but can you apply them when you're sitting behind the wheel? Then you are coached and mentored in your lessons to learn how to drive. And then you get to practice. And practice occurs once you are licensed, but that still doesn't mean you're a competent driver at that point in time. It means you've passed a minimum standard, but you would continue to develop over time. So you need to actually build competence over time. If we think about the different life cycle aspects of a facility or an organisation, so first of all, we need our leaders to think that knowledge and competence resourcing is important. And so it is resourced and it is seen as important. If you're in a design phase, you've got to make sure, for example, you've got competent people undertaking that work. If you're in a construction phase, you need competent people undertaking the construction and also the information transfer of what's actually being built. If you're in the operations, maintenance and ongoing integrity phase, you need to make sure that you've got appropriate knowledge and competence for all persons in process safety that need to have that knowledge. This is across the entire spectrum of the operational aspect. And if you're in a decommissioning or an abandonment phase, you need to make sure you've got competent people undertaking that work as well, because we can also see a number of different process safety related incidents occur during decommissioning activities or abandonment. And in fact, if we think about the Bhopal incident, some of the result of that was because they were partially in a decommissioning phase at the time and had decided to operate again to try and reduce some product inventory. So if we move to engineering and design, and this is probably the one as engineers we're more familiar with because this is the one we tend to do a lot of. This is about applying inherently safer design as the very starting point. So we need to really focus back on what are those inherently safer design principles. It includes the application of robustly engineered safety systems. So what are we putting in and to what standards? What are the design standards of what we're building? This applies across the entire life cycle, from the initial concept all the way through to upgrading facilities and eventually decommissioning them as well. So looking at that, as from a leadership perspective, we need to make sure we've got robust decisions and proving that something is safe rather than unsafe. Now, that's an interesting differentiation here. We should actually be focusing on proving that what we're doing is safe rather than proving what we're doing is unsafe. Because if we're trying to prove it's unsafe, then we're trying to manage safety by assuming no accidents or incidents means it's safe. And that might not be the case. That might just mean that we're lucky and we haven't had the incident yet. We need to measure safety on the presence of safety, not the absence of incident. We need to also be an intelligent customer in what we're doing. So we need to focus on making sure that when we do choose consultants or contractors to do particular roles in what we're doing, we don't just assume that they take over all the risk and we don't need to worry about it because they're the expert. Doesn't mean we have to double check everything they do, but we need to assure ourselves that they're the right people or the right organisation to be doing the work we need. So that's an important aspect of being an intelligent customer. In design, we need to make sure that inherently safer design principles and a life cycle approach are our starting point. From a construction, we need to make sure the as-built meets the process safety design. So looking at how we ensure the design has actually been done well and then built. Did we build what we said we were going to build, or did we build something else? I have seen many things in my career. I have seen things such as pipework being constructed, and the pipework was coated prior to construction, and then obviously it needed to have the coating ground off so elbows could be welded on, for example. And then that pipework was covered in insulation, so you couldn't see it anymore. But in the construction phase, that pipework where the bare metal had been exposed was then never coated again. That's a prime corrosion issue because of corrosion under insulation and no material protection. So how do we know that what's being built is actually what we intended to build? From the operation, maintenance and ongoing integrity, making sure that we have operability and maintainability of our facility. If it's not operable, then people will find ways around working it. If it's not maintainable, it probably won't get fixed to the standard it needs to be fixed and maintained to. We need to embrace risk-based inspection, which is not just another way of saying we're going to put off the inspection. It's actually about it being risk-based. In some instances, we may have to inspect things more frequently than others, for example. And in decommissioning or abandonment, the isolation and decommissioning design. So when we build something, do we actually think about how we're going to get rid of it at the end? That's an important question, particularly this is a prominent one in the offshore industry more so, but thinking about how we're actually going to deal with what we've got left at the end when we decide we don't want to operate that facility anymore. On to systems and procedures. So I've talked about the Centre for Chemical Process Safety defining the management system. I showed you what their management system looked like. And they define it as a formally established set of activities designed to produce specific results in a consistent manner on a sustainable basis. And as I said, there are a number of different management systems that exist. You might have an integrated system or you might have standalone systems. There is no right or wrong answer to that. It is all about what works for your business to get you the outcomes that you're after. You might have maintenance systems, accounting systems, quality systems, environmental systems. As I said, there's a range of them in any organisation. So if we talk about the leadership aspect here, we've got, we need to make sure that we've got robust systems in place and that they're resourced and they're used by everybody. Use of the management system is not an optional extra, no matter what level in the organisation you are. So the leaders cannot be bypassing the use of management systems just because they're the leaders or they're the managers. They don't get to bypass it. They still have to follow the processes as well. From a design perspective, making sure the hazards are assessed and that operating and maintenance procedures are established and that they're able to be followed and they're comprehensive and they're logical so that we can try and minimise the gap we have between what's called work as imagined, what's in the procedure, and work as done, what actually happens in the field. We need that gap between those two things to be as narrow as possible. From a construction perspective, we need to make sure the fabrication and testing standards are all okay and that there are safe systems of work in place. So permit to work systems, those sorts of activities. From the operations perspective, we need the procedures for operations and maintenance and emergency response, for example, as well. Now, these lists are not extensive. There are other things, but these are just a snapshot of some of the aspects in there. And from decommissioning or abandonment, the risk assessments and demolition plans. So this is about documenting how we're going to do something and what we have then done as well. Because I used to work in an industry where, because it revolved around safety of aviation, we used to have a saying, if it's not written down, it never happened. So you'd need to do checks on the fuel quality, for example, every day, and you needed to write down the density of the fuel, the colour of the fuel, the temperature of the fuel. And if you didn't write it down, well, you didn't check it because there's no evidence that you ever checked it. So if it's not written down, it never happened. Now, you need to make sure you don't then get overwhelmed with, well, this is all about just documenting things for unnecessary reasons, because the issue is a system or a book of procedures never saved anybody from an incident. The paper itself doesn't protect you. The application of the paper is what you need to focus on to prevent the incidents. Assurance. Now, this is an issue that we need to look at in terms of the defined program for the systematic monitoring and evaluation. So this includes things like inspection and testing, monitoring, verification, audit, checklists. A range of different things could apply here. Assurance also includes setting and monitoring metrics and performance standards, and making sure that you then manage the organisation based on the results, not manage the results based on the organisation. So we need to remember to focus on, we're managing the safety and the systems, not managing the scorecard that shows the safety and the systems. And the reason why that's important is sometimes we can focus so much on what the metric result is that we spend more time trying to modify or justify the number rather than actually fix the issue that we see happen. This often happens historically it happened. It doesn't happen probably quite so much anymore in occupational safety, for example, where we look at someone had a lost time injury. Well, was it really a lost time injury, or could it be categorized down to something else? Now, are we actually managing the person's injury to the best of our ability, or are we spending more time focusing on what appears on the scorecard? A process safety example is we calculate the volume of a leak that occurred, and miraculously, it's always just under a threshold. So, are we managing the data, or are we actually managing the system? We need to be very clear on what we're trying to do there. And it's also important that we make sure we seek assurance rather than seek to be reassured. Now, that's a really subtle difference in language. But if I'm seeking to be reassured about something, I might ask a question like, so how's the plant operating today? Everything's going okay, yeah? And the way I framed that question is, I've already told you what I want the answer to be. You are going to tell me everything is going okay, because that's what I want to hear, and that's how I framed my question. If I was seeking assurance, I would ask, how is the plant going today? Can you show me what's been going on with the safety, the rates, the productivity, whatever it is? So effectively what we're saying is, I trust what you're going to tell me, but I also want to see some evidence here. I want to understand some detail. That's about seeking assurance, and that's a really important differentiation. So if we think about assurance from that leadership perspective, the assurance process needs to be valued. We need to be questioning some of the good results. If everything's always green on the scorecard, I want to know if it's really green, or is it what we call a watermelon? It's green on the outside, but when you cut it open, it's red in the middle. And we need to embrace the poor results. If something is red on the scorecard, well, that actually tells you you've found something that you can fix. So it gives you something to focus on in fixing. Not fixing the number on the scorecard, but fixing the reason for the number on the scorecard is the important part. So challenge the good, embrace the bad. From a design perspective, we need to make sure that all approvals and appropriate gates are progressed as we go through that process. In construction, we need the quality assurance processes. How do we know that every weld has been non-destructively tested to know that it is a good quality, for example? Pre-startup reviews, making sure that everything is aligned before we start the process. And safety critical element testing, making sure that we understand that the safety critical elements are functioning adequately. From operations perspective, lead and lag metrics are indicators, so understanding what's actually going on in our organisation. Having our audits in place and having our safety critical element inspection as well. And decommissioning or abandonment. So, the quality assurance during decommissioning and abandonment, needing to make sure that we understand what that quality assurance process is. And keep in mind that some of the decommissioning and abandonment, it is the reversal of the design and construction element. So there's often, they're the flip side of each other in that process. Human factors. Now, this is an area where we don't see as much use of human factors traditionally in the process industries as we do in, say, aviation or even healthcare. as other higher risk industries. Now, that is changing, and that is a fantastic thing because human factors has so much to offer us in how we can improve our process safety outcomes. Human factors is all about the intersection between the person, the individual, the job, and the organisation, as shown here in a Venn diagram. So that spot right in the middle is all about that human factors element. How do we make sure we get human factors working adequately in our organisation? I also like to sum it up as making it as easy as possible for the human to get it right, rather than for the human to accidentally get it wrong. So if our systems work well, we will be able to get it right. An example here is when the automated teller machine was first invented. So this is an everyday example in our lives. It was invented with a nice, simple logic process where you went to the machine, you put your card in, you put your PIN in, you got your money out. People started to leave their cards in the machines. So, and the reason for that is because you go to the machine to do a mind-numbing task that you're not really focused on, and you achieve your outcome of, I needed to get that money, so I've got that money, I can go now. But you forget your card because your card's still there. So they changed the logic sequence on the machines. And so in most places now, you go and you put your card in, you put your PIN in, you get your card back, then you get your money, making it as easy as possible for the human to get it right. Other versions now of the machines are either a swipe through or a quick insert and take back out again as well. It's all based on the same theory of making it easy for you to get it right. So you're going to stay till you hit your objective, which is getting your money. So that's a simple everyday example of where human factors works first against us and then for us. There's generally 10 areas that are defined as being part of human factors, and this is a list from the Health and Safety Executive in the UK. So they talk about some specific human factors elements: competence, humans and risk assessments, written procedures, emergency response, organisational change and transition management, safety culture, safety critical communications, alarm handling and control room, maintenance and fatigue. And so they talk about them in that particular area as well. And so that's just a general sort of quick snapshot on human factors for you. We do have a webinar that talks about human factors that is available on our YouTube channel. From the human factors perspective, if we talk about leadership, the leaders need to support the strategies to minimise the human factors impact, so the negative human factors impacts. From a design perspective, it needs to be taken into account with design. So again, how do we make the system as easy as possible for the human to get it right, rather than get it wrong if they make a mistake? From the construction perspective, managing the human factors during construction phase. And this is also about managing as you head towards the end of construction. Then you have a workforce that are potentially becoming less engaged because they're the construction people and they're either going off to no next job or off to another job. And so they may not have their head focused on what they're doing at the time. So managing the disengagement of workers during construction is actually a human factors related issue. From an operational perspective, how is the individual, the job and the organisation interacting to deliver the best outcomes for everybody? And from the decommissioning, again, this is the motivation of workers during organisational change. If they know their facility is going away or their work is going away, then mentally they're in a very different space to if they think they've got security going forward in their job. And so managing that motivation is also part of the human factors element. Human factors is one of those areas that as engineers we need to embrace more with people such as psychologists and ergonomists, because these are the people that actually are experts in human factors, and we need to work more closely with them so we can better understand it. So the final topic is culture, and this is about understanding pretty much the way we do things around here. Is often said that's what culture is. Now, the challenge that we've got is it's an oversimplification. Culture can also be described as the basic assumptions that a collective have developed to deal with their environment, and then they're passed on to new members. So we indoctrinate new members into our group. They start to adjust to our culture. I actually like to extend the definition of the way we do things around here at 3 a.m. in the morning. And the reason why I add that at 3 a.m. part is It's the way that we do things around here when no one's watching me. That actually says truly what the culture is about, because I can behave very differently if someone's watching me. Whereas if no one's watching me, I'm going to behave how I feel, and that may or may not be the appropriate culture that you want to see in an organisation. Professor James Reason did a lot of work in this space, and he actually defined 5 key attributes to a fair and just culture. And they're important things to think about how they apply in your organisation. So it needs to be informed, where relevant data is collected, analysed, and safety information is actively disseminated. So no one's afraid of information or sharing information. That's reporting. So reports are acted upon, and people are confident that they can report without fear of retribution. So am I going to get punished if I report this? If I'm going to get punished if I report it, I'm not going to report it. That's just human nature. It needs to be learning. The organisation needs to learn from its mistakes and make the necessary changes, and then institutionalise that learning all the way through the process as well. It needs to be just. Errors should not be punished if unintentional. But willful deliberate actions do have consequences. And this is an important differentiation. This is different to the idea of a no-blame culture. So the reason this is important is if anybody can get away with doing anything, regardless of whether it's right or wrong, then everybody will get away with doing everything, because there's no incentive to do the right thing if nobody's doing the right thing. So we do need to have a just approach to it, though, where people understand there are consequences to deliberate and willful actions. Whatever those consequences may be, that needs to be determined by the organisation, and it needs to be meted out in a just manner. But if someone makes a mistake, they shouldn't be punished for making a mistake, because everybody makes mistakes. Absolutely everybody makes mistakes. They're unintentional, we learn from them, we move on, we try not to make them again. And that's an important differentiation. And lastly, it needs to be flexible. People need to be able to adapt effectively to the changing demands of the job and the role they're in. So if we look at this from the leadership perspective, the leaders need to demonstrate and really set the culture. The tone is set from the top. From a design perspective, we need to work with others and engagement with the design team. From construction, again, it's about engagement and driving the culture that you want to see on your site. From operations, making sure the decisions and actions drive the culture you're seeking and that it's visible. People can see and feel the culture around them. And decommissioning, again, it's this worker engagement, management visibility, making sure people can see how culture is being applied. So I'm very quickly going to go through an example here of applying these elements to a particular incident that occurred. So back in November 2010, so almost 10 years ago, there was an explosion in an underground coal mine in New Zealand, in a mine called Pike River, and 29 miners were trapped in that particular explosion. There were subsequent explosions that occurred before any attempts could be made to rescue the miners, and they were presumed dead. The immediate root cause was the accumulation of methane that then found an ignition source. But there was a range of other things in the findings. If we look across leadership and the 6 elements that I've talked about, we can understand some of the organisational failures that occurred. And it's important to think about distilling the root causes down in this way allows for very broad learning in our organisations. It doesn't remove the need to determine root causes, though, the direct root causes. This is an extension of that process. So if we think about the leadership, there was a lack of board governance on process safety in this organisation, and there is actually a parliamentary report into this particular, the Royal Commission, into this particular incident in New Zealand that details all of these failings. Management was focused on operations aspects only and not on safety, and in fact they were confusing the two at times. There was issues raised to the board that they had a methane management issue, but it was dismissed as being an operational issue. It's got nothing to do with safety. So this is a flammable gas contained underground, has nothing to do with safety. It was all operational, was their position. Now, obviously, this is very clearly confusing the two. They were focused on mining the coal as much as they could, as fast as they could, without taking the safety aspects into account. In terms of knowledge and competence, there was a lack of understanding of the purpose of the ventilation system in the mine. It was, again, seen as an operational issue, not a safety issue. This is a system that is removing methane and making sure there's fresh air for the miners to breathe. When the ventilation system failed, portable gas detectors were being used, but there was a lack of understanding of their purpose or operation, and often they were being bypassed so operations could continue, so mining could continue. At one point, they did seek an expert opinion on their ventilation system, and then they ignored it because it didn't tell them what they wanted. It actually told them they needed to change a whole lot of things because it was an unsafe facility. So they ignored the result. From the engineering and design perspective, the ventilation fan was located underground, and that had not been done anywhere else in the world, ever. They did a risk assessment on putting it underground on this location, but it was inadequate. And in fact, the actions that came out of the risk assessment when they were making the decision to put it underground were never completed, yet they still put it underground and operated it in that way. They had a methane drainage system installed in the mine because it was a very methane-rich coal seam. But it could not cope with the level of methane produced by the technique of mining they were using at the time. The particular technique they were using was liberating enormous volumes of methane within the mine itself. They couldn't remove the methane effectively. And the location and number of detectors they had within the mine was inappropriate. They didn't have the right number. They weren't in the right locations. They weren't following the advice of the expert that they sought advice from. They ignored those reports. So from the engineering and design perspective, there was a lot missing. From the systems and procedures, there was a lack of management of change applied. So when they decided to introduce the new hydroblasting technique in the mine, they didn't review how the methane ventilation was going to be impacted by it. So there was no risk assessment done on that. The procedures were implemented to record methane levels, but whilst they had action triggers, there was no trigger to do anything with it. So you could just write down that you had high levels of methane and nobody checked it, nobody worried about it, nobody did anything about it, and it didn't stop any of the operations in the mine for safety reasons. From the assurance perspective, so the daily measurements of methane were recorded, but high levels were not reviewed or any actions taken, as I just said. The board received no process safety data in their reports. They only got OHS-related data. They did not ask about catastrophic risk or process safety at all in their board activities, and so they were not seeking assurance on any of the safety aspects that were going on. From a human factors perspective, the equipment that they provided was inadequate. So the ventilation system was not adequate. The gas detectors were not adequate. They were not in the right location, and they were easily bypassed. The instructions for use on gas detectors were largely absent, so people were choosing what to do with them rather than having clear guidelines or requirements as to what they needed to do. And the organisation had no real commitment to monitoring and rectifying issues that were being noted or reported. From a culture perspective, the only thing that drove production at the site was economic pressure. And the schedule was part of that as well. They were just interested in mining as much as they could, as fast as they could, and getting the mine up and running, rather than dealing with the grave safety issues that were occurring at the site. So safety was dismissed at the expense of productivity. So productivity was the king at the expense of safety. The workers bypassed the detectors, and this became the way we do things around here. They bypassed the methane detectors, because if some of the methane detectors went off, they actually shut down the mining equipment, and that stopped the mining activity. And that action was condoned by management because they knew about it and they let it continue. It's interesting to note that at one point in time, the mine actually offered a bonus to the workers if they could mine a certain amount of product by a certain time, even though they hadn't commissioned at the time their main ventilation fan. So the management certainly knew the system wasn't adequate because they still hadn't fully commissioned their ventilation system, yet they were actively encouraging the miners to mine more coal the whole time, regardless of the methane being liberated in that confined space. So that's certainly a culture issue. So I've talked about this non-technical framework, a functional way to look at it. A leadership focus on the functional aspects can certainly provide a robust, non-technical framework to be able to manage and monitor process safety. And this allows us to communicate more effectively with people that are not necessarily technically competent in process safety, because not everybody needs to be technically competent in process safety. They need to understand some things, but they don't need to know how to do some of the detailed calculations, for example. So we need to be able to talk to them in a way they can understand. So there is still complexity in process safety. There's no getting around that. But we need to make sure we can communicate with other people, and we need to make sure that we lead the organisation and understand that the leadership of some of the areas is not technical. It's actually all about people. It's all about the human and how the human interacts with things and other people. And it applies across the entire organisation very broadly as well. So they were the slides I had prepared, and I am happy to now start to get onto your questions. And I see we do have quite a few questions already, so thank you for that. Let me just start to get onto those. So someone's asked, can we consider the one in China warehouse incident too as a process safety incident? Yes, I would definitely consider. There have been a number of process safety related incidents in China in the last few months, where they were simply just things like storage facilities that contained hazardous chemicals of some sort that suffered substantial explosion and or fire impacts. You may remember the Tianjin explosion that also occurred. That too was a process safety related incident that also was ammonium nitrate related, similar to the Beirut incident. What are some of the leading and lagging KPIs for knowledge and competence framework? It's really hard to track for organisations where process safety concepts are new. So some of the sorts of KPIs we're looking at there are things like, are people completing their training as required? Because whilst training is not everything, it's not all about, it's not the only thing you need. It's a fundamental part to build your knowledge to then start to work towards your competence. So is everybody doing the training they need to do as per the schedule? That's one part of it. How are you actually implementing the training activities as well? So sometimes organisations will measure things such as the investment in training per by hours per person, for example. It's important that you do have comprehensive training plans for people so that you know what they're meant to be doing. Then you can actually measure against what they're doing to make sure that you're achieving that. In our process safety lead metrics document, we do talk about some other metrics for competency as well. So if you go to our website, you will be able, under the publication section, you'll be able to download our lead process safety metrics guidance document for free, and that will talk to you about different metrics. How do we focus on the soft skills development, i.e. communication, problem solving, mentality? It's an interesting question around how do we focus on it. The fact is, I think we need to first of all come to a realization that we need to focus on it. We need to really start to get the message out more broadly that process safety is not just a technical thing. We need to be able to communicate it. And if we can't communicate it, we're not going to get the outcomes we need or that we're seeking. So we need to figure out how to best communicate it. We can't just keep saying, well, this is really complex, I'll do the calculations and you just need to do what I say, because that's not working, and it's not going to work in the future either. So we need to take a step back and think about, what are we trying to achieve? What do we need to do to achieve that? Now, critical thinking is an important part of that. Communication skills is an important part of that. Again, there's another webinar on our YouTube channel called, I think it was a webinar on leadership and safety in uncertain times. And in that, I actually talk about communication specifically as one of the key areas. So take a look at that particular webinar on our YouTube channel. That talks a lot about communication. Someone said, can you explain the last procedure in detail? I'm not sure what that question is specifically about, if you want to give me another bit more information on that. How realistic is it to possibly seek assurance via PowerPoint slides in a 15-minute management agenda? Well, I'd say that's probably not realistic at all. You actually do need managers and leaders to get out of their offices and to go and see the sites and engage with people. It's more of a challenge at the moment. Obviously, we have social distancing requirements that need to be met. So maybe we need to be engaging with them via virtual means as well at this time. But at the end of the day, if the only information that executives are getting is what's being fed to them in their executive meetings, they are not getting enough information, and I'll probably guarantee you they're not getting the right information either. But they need to seek information too. So we need to try and help them develop their knowledge, their education, and their curiosity about process safety. But that does mean we need to talk to them in a language they understand as well. We can't just only talk in the language we understand and expect them to figure it out and be curious about it. So it's incumbent on all of us to work together in that space. How would you approach stakeholders, either communities or CEO, in discussing process safety? Sometimes a stakeholder interested and not aligned with process safety. I'd actually challenge that sometimes stakeholder interested and not aligned with process safety. The reason I challenge that is surely the stakeholders are interested in the operation not blowing up. And surely they're interested in, if it's the CEO, for example, they're interested in good reliability and productivity. Because if the plant is reliable, it can produce product, and therefore you have a chance of making money. That is an inherent part of process safety. So we need to start to talk in language they will understand. This means we need to talk in some business language, for example, to the CEO. So the CEOs understand, if we're going to talk about process safety, what are the reliability and productivity gains that we can get when we do process safety well. So all of a sudden, we're not only getting safety, we're getting that, but we're getting other things as well that are really valuable economically to our organisation. That's important. You can talk about the cost of an incident as well. It's always interesting to talk about the cost of an incident. Incidents are very, very expensive. But I also prefer to make sure we talk about the value the process safety can bring to an organisation and a community. So if it's the community as your stakeholder, they do not want to see incidents in your facility, because if they do see incidents in your facility, it potentially is going to impact them, and that is not a good thing. So you want to make sure that you talk to them, you don't talk down to them, you actually explain to them what's going on in terms they understand. But we need to make sure that we're not condescending in how we talk to them either, because just because they're in the community does not mean they're not intelligent people, and they need to be treated intelligently and with respect as well. I've had a fair bit of experience working with community groups from being in process safety management roles, and they are willing to engage with you when you are willing to engage with them on an equal level. When speaking about leadership, who do we think about if we define that management is another aspect? I believe that the manager of an organisation should also behave as a leader so that the organisation can get the wanted results. I would agree with you there. Unfortunately, not all managers are showing leadership actions in what they do. But I do agree that managers do need to step up and become leaders. But there are leaders at all levels in an organisation, and you don't need to be in an authoritative position to be a leader. So you might have, for example, a shift group in your organisation, and that shift group will have a team leader, and that's great. And that team leader might lead that team quite effectively, but there might be another person in that shift group that others look up to and that has a great deal of influence. They're a leader. They might not have the title. So leadership goes beyond management is what I would say to that one. It seems a real balance between engineering, technical and positive culture development. Yes, I would agree. It is a real balance, and it's something we need to come to terms with, and it's not easy. How to transition from process engineer to process safety engineer. This is about gaining experience, and that you need to gain that knowledge and then get that experience and practice. And there are fundamental things that you would do as a process engineer every day that are actually safety related if you think about it. And the way that you apply the process of thinking and problem solving is all about working in process safety as well. So they're not that far removed. Does process safety encompass loss prevention? I thought process safety is all about prevention of the release of materials. Keep the lion in the cage. Once the lion is released, the process is no longer safe, whereas loss prevention is the control of consequences of process relief. I would suggest that it does encompass loss prevention, and the definition I put up at the very start actually talks about loss of control, not loss of containment. Keeping the lion or the tiger in the cage is one thing, but actually not letting it out at all is a much, much better option rather than just dealing with it when it's out as well. So, for example, if you look at the Beirut explosion, there was no loss of containment, but there was most definitely a loss of control. There are many, many instances where process safety incidents have occurred where there has been no loss of containment as the trigger to the consequences developing. So we need to broaden our horizons and think a little bit more about process safety and loss prevention to really bring in the idea of loss of control. Someone has said rule-based system or risk-based process safety for the approach. Well, that depends on where you live. If you live in a country that has a rule-based system, you are going to have to meet the rule-based system. That doesn't stop you exceeding it and applying risk-based approach to that, where you actually see continuous improvement, focusing on as low as reasonably practicable outcomes. So you need to actually understand your own legislative environment. There are advantages and disadvantages to both systems. It's not a one size fits all. I don't think either is the perfect system. I think elements of each probably do get some way to that point. How do we make leadership more responsible? We need to communicate with them and we need to educate them. And that is a key part of it. They need to understand that education process. We do run a specific training course, training program for senior executives and directors on what they need to know and what their accountabilities are in process safety and what they can do about it as part of that process. Okay, why is Beirut considered process safety? There's no process. Again, the idea that we don't talk about process safety just because it's handling of hazardous materials, I think, is a very narrow view of process safety and potentially eliminates our ability to learn from it. I very deliberately in this presentation put on the Herald of Free Enterprise. That didn't involve any process either, yet it failed. And it actually depends on how you define a process. If we're talking about the process of pumping something through a particular piece of equipment, that's one way to define process. Another way to define process is how we actually go about doing something. If you define it that way, then actually it does involve process. How we actually go about storing ammonium nitrate in a warehouse without temperature control, without humidity control, and basically unchanged for years is a loss of control of a process. Therefore, it fits the definition. And just on that Herald of Free Enterprise, I'm not the only person that thinks in this sort of way. There's a book called Incidents That Define Process Safety. It's a CCPS concept book. It's written by John Atherton and Frederick Gill, and actually it mentions things like the Herald of Free Enterprise. It mentions space shuttles. It mentions aircraft-related incidents. These are all about loss of process safety. How is process safety different from other fields? Well, it's really, as I said again, it's about focusing on how we maintain control to prevent the catastrophic incident occurring. Yes, this video will be on our YouTube channel later today or tomorrow, as well as the IChemE Safety Centre website in the next day or so as well. Cognitive biases, how difficult is it to overcome preconceived ideas? So there's a lot of research into cognitive bias, and I would suggest that you take a look at some of the research. It's typically done by psychologists. There's a number of different cognitive biases that exist, and they can really influence how we do things. There are some tools and strategies on how to deal with some of them. Some of them are a lot harder to deal with than others. So, things like having someone in the room that is constantly challenging the decision you're making can help deal with things like confirmation bias, of you only looking for the information that gives you the answer you want, for example. There's a whole lot of different tools involved in that. CCPS pillars of process safety versus human factors elements, are they the same? No, they're not the same. There is some overlap in there. But they're not actually the same thing. There's just some overlap and some good synergies in that space as well. Economic pressure governs the process safety concept in an organisation. How to avoid economic pressure to avoid the catastrophic events. Again, I would take this back. You need to have people focus on the productivity and reliability gain you get from good process safety if that's what's driving them. If you can demonstrate to them that good maintenance and reliability activities, which deliver you good process safety outcomes as well, will deliver you good productivity in your facility, then people will go and agree that that needs to be something that's done. So it's about reframing the discussion you have with people to something that matters to them. Sometimes I have people say, oh, but we should just talk about safety because it's safety and it's important. Yes, it is important, but if only talking about safety in that way is not going to get us the result we need, then maybe we need to talk about it in a slightly different way so that we can get the result that we need. And someone's asked, would I recommend basic literature on process safety for undergrads? Okay, there's a couple of things I would recommend for you there. Some very easy to read books that will tell you a lot of things about process safety were written by the late Trevor Kletz, Kletz. So I would check out What Went Wrong, Still Going Wrong, Lessons from Accidents are the three that I would suggest you take a look at. They will very clearly explain to you all about the concepts of process safety in a way you'll be able to understand and relate to. Also, The Incidents That Define Process Safety is a very good book, and it's got a sequel now called More Incidents That Define Process Safety, and that is also another very good read. It's a little bit about all different sorts of incidents that have occurred. So thank you all very much. I finally got to the last question, and we've run out of time. So thank you very much for your attendance. I hope you found this valuable. We will have this video of the recording up on our YouTube channel in the next day or so, so you'll be able to check that out. And we'll then please invite you to any of our future webinars. We are currently hosting these on quite a regular basis, so check out all the channels where you found this particular webinar advertised, and you will find that there are more webinars available to you. So thank you very much, and I wish you all a safe day. Goodbye.